Children, it is a continuation of the chapter Work and Energy. Now let us discuss about rate of doing work. So the word is there, rate. Then what is rate? That is the rate of doing work. Here, what is rate of doing work? Rate of doing work is nothing but the work done per unit time. Consider two persons A and B are having same weight. They are climbing a tree of same height, and the amount of work done by each equals here. Work done by A equals work done by B, because person A and person B climbs the tree of same height, and here the person A completes the work in 3 seconds and the person B completes that work in 5 seconds. So rate of doing work is more by which person here? That is by person A, because the person A completes the work in less time. So this is rate of doing work. Rate of doing work is more in the case of person A and rate of doing work is less in the case of person B. So here who has done more work in a given time? If you consider here the rate means that is the work done in unit time. If you calculate the work done in unit time, here more amount of work done by the person A in unit time. So person A is having more rate. So rate of doing work is more in the person A and it is less in the person B. A stronger person may be having more rate of doing work. A stronger person may do certain work in relatively less time. A more powerful vehicle would complete a journey in a shorter time than a less powerful one. Then you can say that that vehicle is having more rate of doing work. We talk of the power of machines like motorbikes and motor cars. The speed with which these vehicles change energy or do work is a basis for their classification. Here we have taken the word power. Here if you consider the person A and person B, here the rate of doing work is more in the case of the person A and rate of doing work is less in the case of the person B. So you can say that person A is having more power. Person A is having more power. Here rate of doing work can be expressed in the term power. Then what is power? Power measures the speed of work done. That is how fast or how slow work is done. So you can say that power is defined as the rate of doing work. So rate of doing work is termed as power. Power is nothing but rate of doing work. Rate of doing work means work done per unit time. That is nothing but the rate of transfer of energy also. Rate of doing work is nothing but rate of transfer of energy, and the transfer of energy per unit time or amount of work done per unit time is measured in terms of power. So let us write what is power. Power is the rate of doing work. So let us write what is power. So write power is defined as the rate of doing work. Rate of doing work or the rate of transfer of energy or the rate of transfer of energy. So, what is power? Power is defined as the rate of doing work or the rate of transfer of energy. So, you can write, therefore, you can write that power equals work by time. Work by time. Let us denote the power by the letter capital P or small p. So write P equals W by T. W is the work done. Then what is the unit of power? The unit of power is watt. That is, the scientist named James Watt, because of his honor, that is in the honor of James Watt, the unit of power is considered as watt. So what is the SI unit of power? SI unit of power is watt. And its symbol is W. So power is equals to work done by time. So P is equals to W by T. Then SI unit of power is watt. What is the SI unit of power? SI unit of power is watt and its symbol is W. Then how will you define 1 watt? Definition of 1 watt. Right? Definition of 1 watt. Definition of 1 watt. So 1 watt is the power of an agent which does work at the rate of 1 joule per second. So if an agent done the 1 joule of work per second, here 1 watt is equals to 1 joule per second, and 1 watt is the power of an agent which does work at the rate of 1 joule per second. So write 1 watt is the rate of 1 joule of work, rate of 1 joule of work, 1 joule of work done per second, rate of 1 joule per second, that is 1 watt equals, you can write 1 joule by 1 second. 1 joule by 1 second, that is, you can have that 1 watt is equals to 1 j s to the power of minus 1. 1 watt is equals to 1 j s to the power of minus 1. So, we can also say that power is 1 watt when the rate of consumption of energy is 1 joule per second. And also we can define, or also we can say that power is 1 watt when the rate of consumption of energy is 1 joule per second. We can say that, the power is 1 watt if the rate of consumption of energy is, if the rate of consumption of energy is rate of consumption of energy is 1 joule per second. 1 joule per second. So it is a rate of consumption of energy or rate of doing work. Both are 1 joule per second. 1 watt is equals to 1 joule per second. And you know that this watt is small unit. Watt is small unit, and the larger units are kilowatt, and also we can have some other units, kilowatt hour, etc. So you know that the larger unit is kilowatt or kW. So you know that 1 kilowatt is equals to 1000 watts. That is 1 kilowatt is equals to 1000 W. And also you can say 1 kilowatt is equals to 1000 joules per second. 1 kilowatt is equals to 1000 joules per second, or 1000 joules per second is 1 kilowatt. As 1 watt is equals to 1 joule per second, 1 kilowatt is equals to 1000 joules per second. The power of an agent may vary with the time. In that case, we can use the average power. So what is that average power? Average power is the ratio between the total work done divided by total time taken. So average power is obtained by dividing the total energy consumed by the total time taken, or total work done divided by the total time taken. So here what happens, in many cases the power of an agent may vary with the time. This means that the agent may be doing work at different rates at different intervals of time. Here, if unequal work is done in unequal intervals of time, in that case we have to take average work done, or that is the average rate of doing work. That is nothing but average power. So let us write that average power is the ratio between the total energy consumed also you can take total work done consumed and total time taken So you can write average power equals, right, in the numerator total energy consumed total energy used or consumed or converted or transformed, whatever it may be, total energy consumed divided by total time taken. This can also be taken as total work done, or you can take total work done also. Both are same here. Total energy consumed or total work done. So you can take average power is equals to total work done by total time taken, or total energy consumed by total time taken. Now let us discuss about commercial unit of energy. The unit joule is too small, so it is inconvenient to express large quantity of energy in joule. The energy used in households, industries, and commercial establishments are usually expressed in other units. You know how much unit of electricity is used. That is mentioned in the electricity bill. What is that unit? That is the commercial unit of energy, which is equals to kilowatt hour. 1 kilowatt hour means 1 unit. So the bigger unit of energy is kilowatt hour. That is called the commercial unit of energy. 1 kilowatt hour is that is equals to 3.6 into 10 to the power of 6 joules. So you write commercial unit of energy. The unit joule is, so right, to measure or to express large quantity of energy, bigger unit called kWh, kilowatt hour. Kilowatt hour is used. It is called commercial unit of energy. It is called commercial unit of energy. It is called commercial unit of energy. And what is 1 kilowatt hour? That is amount of energy used at the rate of 1 kilowatt. Then what is 1 kilowatt hour? So take what is 1 kilowatt hour. So that is the energy used in 1 hour at the rate of 1000 joules per second. So what is 1 kilowatt hour? 1 kilowatt hour is the energy used in 1 hour at the rate of 1 hour at the rate of 1000 joules per second. 1000 joules per second. That is nothing but 1 kilowatt. You know that 1000 joule per second is equals to 1 kilowatt. So if 1 kilowatt hour is used in 1 hour, then the power becomes 1 kilowatt hour. Then the energy becomes 1 kilowatt hour. And it is equals to, let us calculate. It is already told that it is equals to 3.6 into 10 to the power of 6 joule. How it becomes 3.6 into 10 power 6 joules? Let us find out here. That is 1 kilowatt hour. You know that 1 kilowatt means 1000 watts, right? That is 1 kilowatt into 1 hour. 1 kW into H. 1 kW means 1000 watt. 1000 watts. 1 hour. 1 hour means 60 into 60 seconds. You know that 1 hour equals 60 minutes. And 1 minute is equals to 60 seconds. So it becomes 60 into 60 seconds. Then you can take 1000 watt into 60 into 60. 6 6 are 36. 3600 seconds. And if you multiply this 1000 into 3600, you will get 1 into 36, 36, 1, 2, 3, 4, 5. Put 5 zeros. 1, 2, 3, 4, 5 joules. And that you can write 1 kilowatt hour equals, you can write here, if you put 3.600000, here 1, 2, 3, 4, 5, 6. 6 digits are taken after the decimal point, so it becomes 10 power 6 joules. 10 power 6 joules. So it is 1 kilowatt hour equals 3.6 into, you can leave this 5 zeros as it is not having value after 6. So you can write 3.6 into 10 power 6 joules. And in the place of 1 kilowatt hour in the electricity bills, the term unit is used. So 1 unit means 1 kilowatt hour. The energy used in households, industries and commercial establishments are usually expressed in units. That unit is nothing but kilowatt hour. Electrical energy used during a month is expressed in terms of kilowatt hour, that is nothing but in terms of unit. 1 unit means 1 kilowatt hour. So you take the word unit is used to express the energy used. Energy means here it is electricity. Energy or electricity. Electricity used in households, industries, households, industries and commercial establishment and commercial establishment. Commercial establishment and this unit. So 1 unit equals what? 1 kilowatt hour. 1 unit equals 1 kilowatt hour, and that is equals to what? 3.6 into 10 power 6 joules. So here 1 unit is nothing but 1 kilowatt hour. If 1 kilowatt hour electricity is used, then that is termed as 1 unit. If 20 kilowatt hour electricity is used, then it is termed as 20 units. So the term or the word unit is used to express the energy used in households, industries and commercial establishment. So then what is the commercial unit of energy? The commercial unit of energy is kilowatt hour. Now let us solve some numerical problems based on the work and energy and also rate of doing work power. The question: a lamp consumes 1000 joules of electrical energy in 10 seconds. What is its power? So here what is given? Energy is given. Energy equals how much? 1000 joules. That is nothing but equals to work done. So you can take energy consumed is nothing but work done. So you take that is W. W equals energy equals 1000 joule. And time is given. Note down that time equals, that is 10 seconds. 10 seconds. Then you write power of a lamp is equals to. So here P equals question mark. You write P equals, that is power of lamp equals, you can write the relation W by T, that is P equals, what is W, that is the energy consumed, work done, 1000 by 10. You will get 100 and the unit is watt. Here 0 cancels, you will get 100. Therefore, you can say that power of a lamp is, therefore, power of a lamp is how much? 100 watts. 100 watts. Then you take one more question. Now let us take one more question. A certain household has consumed 250 units of energy during a month. How much energy is this in joules? Here energy consumed in terms of unit is given, that is 250 units. We have to convert this into joules. You know that 1 unit equals 3.6 into 10 power 6 joules. So you write, that is how much energy consumed? Energy consumed equals 250 units. You know that is equals to 250 kilowatt, and also you can take it as 1 unit equals 3.6 into 10 power 6 joules. That also you can write here, that is 250 into, or you write 250 kilowatt hour, that equals 250 into 3.6 into 10 power 6 joules. 3.6 into 10 power 6 joules, that you will get, here you multiply 25 into 36, 25 into 36 or 36 into 25 you take, 36 into 25, 25 6 are 150 and 25 3 is 75, that is you will get 90. So it becomes 900. 900 means here point is there, 90.0 means again here 250 is there. So you will get 250 into 3.6 equals 900. 900 into 10 power 6 joules. Then you can have 9 into 10 power, here remove that 20 and take extra power 2 here, that becomes 9 into 10 power 8 joules. 9 into 10 power 8 joules. So here you can say that how much energy is in this joule. This is 9 into 10 to power 8 joules. Take one more question. An electric heater is rated 1500 watt. How much energy does it use in 10 hours? So you take, here the power is given. Power equals 1500 watts. 1500 watts, it is the power, and it is used how much time? That is T is equals to 10 hours. 10 hours, and that is equals to, you can convert that into seconds, 10 into 60 into 60 seconds it becomes. Now you write the formula for power. Here we have to find out energy, and power is equals to Power is equals to energy or work, energy consumed or work, energy by work, or also you can write energy consumed or work done, whatever it may be. So you take energy or work in the numerator, and time taken. Here you have to take time taken. Then power is given, that is 1500 equals, or also you can take here, if you take the symbol is P, this is E, this is by T, then here you can take P into T is equals to E. So E is equals to P into T. E is equals to P into T. P is power, that is power into time. Energy is equals to power into time. 1500 into 10 into 60 into 60. 10 into 60 into 60. Then here you can have 15 6 are 90, 96 are 9 6 are 54. So you will get 540 1 2 3 4 5 6. Here you will get the product of these two. 15 into 60, 6 into 6, that is 15 into 6 is 90, 90 into 6 is 540. So the product of this and this and this, 6 into 6 into 15, you got 540. Extra how much zeros you have to put? 1 2 3 4 5. Extra you put 5 zeros. 1 2 3 4 5. So here if you express in terms of 5.4, so you can write 5, that is joules here, 5.4000000. Here 3 plus 3 6, 6 plus 1 7 digits you got after the decimal point. So you must take the power 10 power 7, 10 power 7. So in short you can write 5.4 into 10 power 7 joules, 10 power 7 joules. So here the energy does or energy consumed or work done, therefore energy equals 5.4 into 10 power 7. 5.4 into 10 power 7 joules.